Alright, so we just talked about using the inversion method to sample for some distribution. Now we're going to talk about rejection sampling. So this is also a way to sample from some probability distribution, but it instead uses the Monte Carlo method. So what we do is we sample values from some proposed distribution, and then we accept or reject that sample based on whether or not it falls within a PDF that we know have a sample from. And if it falls outside of the PDF, then we reject the sample. Okay, so let me use this little diagram to better explain that. So say we have this equilateral triangle here, and we have some circle inscribed within it, and we're given some method to generate random points uniformly within this triangle. In rejection sampling, what we do is we will sample uniformly within this triangle. If the sample does not lie within this circle, we reject it. And if it does lie within it, then we will keep it. And this is actually going to estimate pi for us by using the ratio of the number of points that we've sampled that lie within this circle versus the number of points sampled. And then B is just another way to do the same method. So instead of a triangle, we just have some square and a circle inside, and we reject everything that's not inside of the circle. Alright, sorry, my computer fan is just quite loud right now. On to number 1. In method A, suppose there are k points out of all n points sampled that lie within the triangle's tangent circle. Then a formula for the estimated value of pi is... Okay, so we have k points that we didn't reject out of n points. So k over n should give us roughly the probability of sampling a point that lies within this circle here. Another way to express that is through the ratio of the areas of these two shapes. So if we take the area of our sphere, let me just write that out, over the area of our triangle, that should give us the probability of sampling some point within this sphere. So intuitively, if the area of the sphere is really small, say it's like just a really small sphere inside here, then this ratio is going to be a lot smaller because it's going to be a lot less likely to sample some point within this like small sphere. Alright, so what is the area of the sphere? So let's say r is the radius, then we know that the area is pi r squared. And then for this equilateral triangle, since it has an inscribed circle of radius r, the equation for this area is just 3 times root 3 r squared. Alright, so now that we have this ratio, we can just simplify this, and this will give us an estimate of pi. So let's simplify. Alright. Pi. Okay, so now as you can see, if we just repeat this process and just keep sampling, this will give us this value here, which should become an estimate of pi. Okay, number 2, this is the same thing, but now we're going to go over the example for the square. So let me just draw this again. We have some square and a circle inscribed within it with radius r. And then again, we have k points out of n points that were not rejected. And this should be, again, equal to pi r squared over the area of our square this time. So what's the area of our square? Well, each side here should be 2r, so this should just be 4r squared. Alright, and then again, we just simplify, and we end up with this formula for pi.